Hi, this is Mrs. Lloyd with Lesson 21, Session 2 for 7th grade math, iReady, solving problems involving percent change. Our learning targets remain the same. Same and different. On page 453, a county fair sells adult and child tickets. Last year, the fair sold 24,600 adult tickets and 16,400 child tickets. This year, the number of adult tickets sold increased by 10%. Well, can't get anything to write. Sorry. And the number of child tickets sold decreased by 20%. There we go. What is the overall percent change in ticket sales from last year to this year? So this is a multi-step problem. Let's think about what we can do. 24,600 adult tickets, and it increased by 10%. So if we have 10% and it's an increase, we can add 100% to get 110%. $24,600. Change 110% to a decimal times 1.10. 27,060. So that is our new number for adult. Maybe we should label. And then child tickets decreased by 20%. So since it's a decrease, we need to do 100 minus 20. So that would be 80% we would use. 16,400 times 80% is 13,120, and that's our child number. What is the overall percent change in ticket sales from last year to this year? So we need our totals. Last year, total would be 24,600 plus 16,400 for a total of 41,000. And this year, we use our new numbers here, 27,060 plus 13,120 for a total of 40,180. I don't know why I decided to use a comma all of a sudden. Let's get rid of that. So those are our two numbers. What is the overall percent change? So for percent change, if you remember, we can do the original amount in the denominator, our new amount in the numerator. When we divide those two, we will have a decimal. So we can multiply that by 100 to get a percent. 40,180 divided by 41,000 is 98%. So what is the overall percent change in ticket sales? The percent change then, they didn't give us enough room. If this time we got 98%, we would have started with 100%. The percent change is 2%. We could have also done that using subtraction. So 41,000 minus 40,180. Let me check that. Would have been 820 over 41,000. And that would have given us, we needed to multiply that by 100. Let me. Times 100, that would have also given us 2%. So a couple different ways you could work that problem. Let's see how iReady did it. That looks like what we did the first way. And this looks like what we did the second way. On page 455, what is the overall percent change in the ticket sales? Is this a percent increase or a percent decrease? So we know that the overall was 2%, and it went from 100% to 98%, so we know that it was a decrease. Look at the first modelet. What does 0.98 mean in the context of the problem? 98%, which is the ticket sales in the second year, or maybe it would be considered current year. Let's just say this year. I think that might be how they worded it. And then think about the two modelets. How are they the same and how are they different? I hope you see that you're doing the same math. There's just always multiple ways that you can do that. Number 4, the number of adult tickets sold increased by 10%. The number of child tickets sold decreased by 20%. What is the overall percent change in tickets, why is the overall percent change in ticket sales not a 10% decrease? So intuitively, that might be what we would think. We might be thinking that an increase of plus 10 and then a decrease of 20 would be minus 20, would be an overall negative 10, but it doesn't work that way. You have to consider the number of tickets sold. So let's just say that. Because we have to consider the number of tickets sold. And if you remember, we sold a good bit more adult tickets than child tickets. How does the percent change help you understand how the ticket sales changed better than the amount of change alone? So when we look at it, it was only a 2% change. 2% is not a lot. We also could look and see that it was 820 tickets difference. So 820 tickets does not tell us if that's a large or small change. To some people, 820 might be large, and to others, that might be small. It all depends on how many total tickets we sold. %2 does indicate a small change. And think about all the models and strategies you have discussed today. Describe how one of them helped you better understand percent change. Feel free to write whatever you want to write there. And we will go on to some more practice problems. One year, an estimated 598,000 sandhill cranes migrated in March. The next March, an estimated 660,000 sandhill cranes migrated. To the nearest percent, what is the percent change in the number of migrating cranes from the first March to the next? Is this a percent increase or a percent decrease? Well, we can answer part of this without even doing any math. We went from 598,000 to 660,000, so we know that this is a percent increase. So let's use the formula this time. The first or original amount was 598,000. And let's do the difference. So what is 660,000 minus 598,000? That would be 62,000 divided by your 598,000. And then if we multiply that 100, that will give us a percent. Since it told us to go to the nearest percent, we're probably going to get a decimal, and we will round. 62,000 divided by 598,000. Multiply that by 100. I get 10.3, so I'm going to say, since it's not exact, I'm going to use the correct symbol, approximately 10%. And we already indicated that that is an increase. Number 8. A large container of breath mints has a mass of 50 grams. A small container has a mass of 10 grams. What is the percent decrease from the mass of the large container to the mass of the small container? So we're going from 50 to 10. And we're comparing it from the large, so we're going to divide it by 50. And then we will multiply by 100. 50 minus 10 is 40. Divided by, not 40, 50. And that will give you 80%, and we already know it was a decrease. And number 9, what is the percent change from 40 to 51? Is this a percent increase or a percent decrease? We're going from 40 to 51, so we know that it is an increase. And it says from 40, so that's our original, or where we're starting at. And then we need to do the difference. 51 minus 40 times 100. 51 minus 40 is 11. Divided by 40 times 100, 27.5%. We have an example here. On Friday, 375 people attended the school concert. On Saturday, 250 people attended the concert. What is the percent change in attendance from Friday to Saturday? So I hope that you can see that it is a decrease because it went from 375 to 250. But you still do the difference or subtract. And it says from Friday, so the Friday number goes in the original, 375, to get 33.33% decrease. I think we're going to use some of those numbers again. On Sunday, 300 people attended the school concert in the example. What is the percent change in attendance from Saturday to Sunday? So Saturday's number was 250. And it says from Saturday, so that means 250. 300 minus 250, those are the numbers I'll be using. And then we'll multiply by 100 to get our percent. 300 minus 250 is 50. Could probably do this one without a calculator. %. And it went from 250 up to 300, so maybe we should say 20% increase. Number 2, a payment increases from $700 to $945. What is the percent increase in the payment? So from 700, that's our original, to 945. So we do the difference, 945 minus 700. $945 minus 700 is 245. 245 divided by 700 times 100. I get an increase of 35%. Number 3. Pillar has 40 shells in her collection. She goes to the beach. She collects 6 more shells in the morning and 3 more shells in the afternoon. What is the percent change in Pillar's shell collection from the beginning of the day to the end? So what are we starting at? We're starting at 40. What are we ending at? 6 more in the morning and 3 more in the afternoon. 6 plus 3 means we would have 49. I do not know why it does that. I think if I lay my hand on it, just certain ways it doesn't write correctly. So 49 minus 40, which is 9. So I get 22.5%, and that is an increase. Number 4, last year an organization spent $500 on food for an event 100 people attended. This year they plan for 120 people to attend the event. Food costs the same per person as it did last year. From last year to this year, what is the percent change in the money the organization spends on food? So $500 on food for 100 people. That's a unit rate we need to find. $500 for 100 people means that it is $5 per person. This year, 120 people are attending, so how much are they going to spend on food? 120 times 5. Food is going to cost $600 this year. We had to do that to be able to do what we really need to do from last year to this year. What is the percent change in the money the organization spends on food? So last year was 500, that's our original. This year is 600 minus that 500 times 100. 600 minus 500 is 100. And so that means there's a 20% increase. And I believe this is the last one. The original cost of a shirt is $40. A store manager marks up the cost by 20% to get the selling price. During a sale, the store manager marks down the cost of the shirt by 20%. What is the percent change from the original cost to the sale price? Is this a percent increase or a percent decrease? So again, not quite as straightforward as you might think, because you might think going up by 20 and then down by 20 means it's an overall 0, but that's not the case. Let's work it out. $40 markup of 20%. So 100 plus 20, because it's a markup, is 120, so I can multiply that by 120 as the 120% multiplied by 1.20, the decimal, and I will get $48. Now I take that $48 and we mark it down 20%. And so since it's a mark down, I can multiply that by 80%. So $48 times 80%, $38.40. And so it wants to know what is the percent change from the original cost to the sale price. So the original cost is 40. Sale price, so this is our sale price, I better write it down, is $38.40. So 40 minus $38.40 times 100. $40 minus 38. 40 is $1.60 divided by 40. 4%. And 38.40 is less than the 40 that it originally cost, so this is a 4% decrease, and this store owner lost money on that because he sold it for less than what it cost him. And that is the last one for this lesson. Have a great day.